Computer Numerical Control (CNC). What is a CNC machine? Numerical control is the automatic control of machine tools and 3D printers by means of a computer. A CNC machine processes a piece of material to meet specifications by following a coded programmed instruction without a manual operator. Components of a CNC machine. Numerical control is described as a technique to control various functions of a machine tool with an input. CNC is a microprocessor-based system, the heart and the brain of a CNC machine. Following are some of the components of a CNC system. Central Processing Unit (CPU), Input Devices, Machine Control Panel, Programmable Language Controller (PLC), Servo Control Unit, and Display Unit. Next is some of advantages of CNC machine over other conventional machines. 1. Reduced development time. 2. Improved stock management, higher quality end products, cost savings, surplus productivity, increased profits, continuous use, consistency, precision, and redundancy. The disadvantages are unemployment is a major disadvantage. Automation decreases the need for manpower and fewer laborers are hired. That said, the need is now shifting to software engineers and mechanical engineers, and education and training will have to adjust to meet the need. As the demand for manual machine operator decreases, fewer and fewer need of students adopt those skills. This could eventually lead to the complete loss of long preserved skills. Automation decreases the need for manpower and fewer laborers are hired. These machines are more expensive and require a greater initial investment than other machines that can be operated manually.
Now the working of CNC machines. Normally these CNC machines are controlled by some G and M codes. Each numbers or code is assigned to a particular operation. That means that each operation is controlled by a particular code in the CNC machines. These codes are normally typed in manually and nowadays to a CAD by machine operators. Now machine operators are normally used to write these codes. They may be generated by the computer software itself. Actually, the numerical codes refers to the operation of machines which tools using numerical data. And the production of these complicated components like that is used to make many components, and it requires a large of accuracy in the transfer of information from a man to a machine. Actually, these codes have been transferred from man to a machine. A CNC or computer numerical control machine it's a high precision tool that's computer controlled and make repeated and accurate movements. And we all know that it's a program. It takes the computer generated code and converts it with the software to electrical signals to perform some functions. And the signals that we give or the computer generates are the what control the CNC motors and directs them to move in small increments that are highly precise and repetitive. Given here is the block diagram of CNC machine. It consists of an input device and a machine control unit, which is the most or the brain of the CNC machine. This is MCU, which processes the data and gives the necessary output by the machine tool. And further, you can refer the block diagram to understand more about the CNC machine.
Drills are the most commonly used tools for creating holes. Short spotting drills are used to create shallow, conical holes, preventing longer drills from wandering off center. Frequent retracting, known as peck drilling, helps clear chips. Screw machine drills are much shorter and can drill straight, accurate holes without spotting. Programming a CNC machine to drill holes is simplified with the use of canned cycles. The table and spindle initially traverse to the starting position of the first hole. The G81 command, followed by various parameters, initiates the can cycle. G81 is a modal command, meaning it stays active until another command cancels it. Drilling additional holes only requires specifying new coordinates.
Now given here is the operator panel of a CNC machine where the controlling of the CNC machine takes place. Now the types of CNC machines include turning centers, milling centers, vertical machining centers, horizontal machining centers, drilling machines, EDM machines and laser cutting machines, and we'll discuss them further on our next slides. And the first we are going to discuss about the turning centers. They are numerically controlled multi-axis or even multi-turning axis as well. Vertical milling machine, three dimensions, three-axis CNC machine, and even a manual lathe is also referred to as a turning center. You just know that lathe, it's just the same thing as we have studied earlier, and the picture is given in the PPT and you can refer that. Now we will discuss about the milling centers. The milling is used to cut and shape the stock materials, and it utilizes the computerized control to operate and manipulate the machine tools. Now vertical machining centers. These milling machines are vertical oriented spindles, and they can approach work pieces mounted on table above and commonly perform 2.5 or 3 axis machining operations. Now the horizontal machining centers. They have the spindle in the horizontal orientation, and they also favors the uninterrupted production work. And there's also a good reason that the horizontal orientation encourages chips to fall away, so they don't have to be cleared from the table. That means that the remaining parts would be fall away from the machine, so that they do not need to be cleared near the table. Now drilling machines like CNC drilling is commonly implemented for mass production, as it is not used for some small productions that is computerized, and it is also a multi-function device which can sometimes do the mill and sometimes the turning purpose. And there are a variety of semi-automated drilling machines nowadays. Now the EDM machines. The EDM machines incorporate automatic strategy to produce the program needed for the optimal erosion process. And by inputting a minimum data, the CNC can analyze the optimal erosion process, showing the number of requested electrodes and the unsize, and it automatically generates and executes the program on itself. Now the last and final one is the laser cutting machines. It is a CNC equipment that adopts fiber or CO2 or UV laser beams to engrave or cut the metallic or non-metallic materials. That means that we are also familiar with the laser cuttings, as it uses the laser beams to cut the metallic or non-metallic materials. It is composed of laser machine frame, CNC controller, a laser power supply, laser generator, laser tube, laser head, and laser mirror, laser lens, water chiller, stepper motor or servo motor, air compressor, gas cylinder and gas storage tank, and the dust extractor, air cooler filler, dyer, dryer, CNC laser software, and CNC laser system. These are things included in a laser cutting machine, and it's used to cut metallic or non-metallic materials. Now, what are G and M codes? Now, G code stands for geometric code and contains three-dimensional movement of the machines. And M codes control the miscellaneous machine functions and it activates the PLC, that means the program logic controller of the machines. And these G and M codes controls the working of the machine. As these are codes which are given by the humans or they taken by the computer itself, and they convert the program using a software in an output. These are the basic G codes, starts within G00, G01, etc. etc. These are the M codes or basic M codes with M00, M03, M04, etc. Now we can go through the parts of a CNC machine. A CNC machine consists of a major 6 parts. First, the input device, machine control unit, machine tool, driving system, feedback device, display unit, which I have given earlier in the presentation. As the block diagram, we can see that you can find these major 6 parts in that block diagram given earlier.
Scope for CNC machines. CNC machines are controlled by software. So they have various functions such as drilling, routing, milling, and cutting, which makes them extremely versatile. The specialty of CNC machines are the it has minimum human involvement, which means that it helps in greater productivity and efficiency. Now, since human involvement is least, uh, it helps in getting the perfect output without any imperfections. Advancements in CNC machines. So, only a decade ago, CNC machines were used predominantly by manufacturers and factories on large scale industrial projects. Since the size of CNC machines were large, they weren't used mainly for household works or for small scale productions. But now, since the scale is reducing, the general public is able to acquire powerful CNC machines to create their own work. So this has opened up potential market for buyers and is appealing to a large amount of people. On this slide, I'd like to show you CNC machines, two types. One on the left is used in industries. One on the right is used for small scale work or in households. This shows the difference and advancement in technology in CNC machines. Next is manufacturing developments. Since CNC machines themselves have become more intricate and advanced, manufacturing companies are able to produce even more precise products, which pave the way for advanced developments such as nanotechnology. So, CNC machines are now playing an important role in the development of nanotechnology. And till 10 years ago, the programming for CNC machines were very complicated and took a long time to complete. But now, due to developments, they're relatively easier and highly effective. And you can expect more changes in the years to come.